All right, you are welcome again. How you doing and how is everything? Now let's take a look at this topic: trigonometric ratio of compound angle. Trigonometric ratio of compound angles. Now, in this lesson, we're going to show that sin A plus B is equal to sin A cos B plus cos A sin B. And then we're also to show that cos A plus B is equal to cos A cos B minus sin A sin B. Please pay attention to this lesson. It's very, very important. Okay, let's pay attention. Now let's go. We have a right angle triangle. Then let's take a look at this right angle triangle. We have our X, we have our Y, then we have our R. Okay, good. And then we have our theta. Now let's assume we want to find our X and then our Y. Hello. Now let's go. Using cosA. Okay. Now, when you say sin theta, what will sin theta give you? Sin theta will give you opposite all over hypotenuse. And then in this our triangle here, we have our opposite to be Y all over our hypotenuse to be R. Okay, good. Now we have sin theta equal to Y all over R. Please, let's make Y the subject. We want to find the value of Y. So we'll see that Y will give us R sin theta. Okay, that means this Y, we can replace it with R sin theta. And then the other side, we also find cos theta. So when we say cos theta, we're going to have adjacent all over hypotenuse, which is going to give us X all over R. And then when we try to make X the subject, we're going to see that X is equal to R cos theta. So this our X, we can actually replace it with R cos theta. Hello. Now we see that our opposite, pay attention, we see that our opposite is equal to R sin theta. And then our adjacent is R cos theta. Hello. Our opposite is R sin theta, and then our adjacent it is R cos theta. Now let's go properly. Let's take a look at this triangle OSM. Let's take a look at this triangle OSM. Then we have that this are triangle OSM. We have our angle to be angle A. All right, angle A. Now let's see another triangle OPS. We have another triangle OPS. Now let's transform this, or let's join this together. So when we join this together, let's join it like this. Okay, so that we're going to have OPSM. Okay, OPSM. And then you know that our OPS is having angle B. All right, now let's go. We have OPS, triangle OPS. Now in this triangle OPS, let's have our hypotenuse to be 1. Let's have our hypotenuse, which is OP, to be 1. And then we have our angle B. How can we find the side PS? And then in any triangle, when you have two sides, you can find the other side. Then when you have one angle and one side, you can also find the other sides. Okay, now in this case we have one side and one angle. How are we going to find the rest of the sides? Now let's go. We want to find side PS. So let's take a look at this sin theta. Let's make use of cosA. Okay, cosA. Now when you say sine is going to give us opposite all over hypotenuse. Now let's say sin B. We are looking at triangle OPS. Now And then this triangle OPS is having the angle B. So we're going to say sin B is going to give us opposite all over hypotenuse. And then our opposite is what? Is PS. PS all over our hypotenuse is 1. So that means we have sin B is equal to opposite all over hypotenuse, and then our opposite is PS, and then our hypotenuse is 1. So we are looking for PS, line PS. So we can say that PS is equal to sin B. Now let's label PS to be what? Sin B. Alright, good. Let's go. Let's find line OS. Let's find our what? Line OS. Then you discover that our line OS is what? Is the adjacent. Line OS is the adjacent. So we can make use of cosB. So cosB is going to give us adjacent all over hypotenuse. And then cosB, our adjacent is OS. And then our hypotenuse is 1. So we are looking for OS. We make OS the subject. We're going to have cos B. So we say that our line OS is cos B. Now let's write it cos B. Okay, good. Now let's go to triangle OSM. We are done with triangle OPS. Now let's go to triangle OSM. So in triangle OSM, we have our hypotenuse to be cos B. And then we have our theta. So but we don't know our opposite, and then we don't know our adjacent. So our opposite is SM, and then our adjacent is OM. So we want to find our opposite, which is SM. So let's also use sinA. You know, in this OSM, our angle now is A. Now let's use sinA. So we're going to say sinA is equal to, we have opposite all over hypotenuse, right? Now in this case, we have our opposite to be SM all over our hypotenuse is cos B. All right. Now making SM the subject, we're going to have sinA cos B. That means our opposite, which is SM, is equal to sinA cos B. Is that true? Yes. Now let's go. Let's also find our adjacent, which is OM. Our adjacent, which is OM. In this case, now we discover that we know our hypotenuse, which is OS cos B, and then we know our opposite SM, which is sinA cos B. Let's find OM, which is adjacent. Now let's use cosA. So cosA is adjacent all over what? Hypotenuse, and then our adjacent is OM, which is what we are looking for. All over our hypotenuse is cos B. In this OSM, triangle OSM, our hypotenuse is cos B. So looking for OM, let's make OM the subject of formula. So in making OM the subject of formula, we're going to have cos A cos B. So we see that our adjacent, which is line OM, is giving us cos A cos B. All right? Yes. Now let's go. In this place now, we have our two triangles and we join them together. Okay. Now let's draw a line from P perpendicular to line OM. P perpendicular to line OM. That is, let the line bisect OM from P. Now at the point, let's call it F. The point, let's call it what? F. Okay, now let's go. You know, as we call this line F, it also cut line OS. It cut line OS. Now let's name the point H. Let's name the point H. Now you discover that as we draw our line PF, we can see clearly that we have another triangle, triangle OPF. We have another triangle, triangle OPF. Okay, now let's go. Let's also draw a line from S perpendicular to PF. Draw a line from S perpendicular to PF. Okay, that is, let it bisect PF. So we're going to call it point K. All right, now let's go. Now you discover that before we draw this line, we have our triangle OPS. Okay, so we have our, in this triangle OPS, the angle OSP is what? 90 degrees. Okay, now I will draw a line now. That means we cut a portion of this 90 degrees. As we cut the portion of this 90 degrees, is making an angle. And then this angle is in the line of OS. The line of OS. And then in the line of OS, we have angle A. So we can simply say that this cut portion of this 90 degree is an alternate angle to A. Hello, is an alternate angle to A. So we can simply say that this cut angle is what? Is A, because alternate angles are equal. Now, and then you discover that as we draw the line SK, we are having a triangle PKS. We are having a triangle what? PKX. And then PKS is a right angle triangle, and then we have our 90 degrees here. So the other side of it, we have A. So we can simply say, we have, initially we have 90 degrees. So we can simply say that this angle will give us 90 minus A. Okay, and then we have our angle KPS. Angle KPS to be what? A. Now let's go. I want us to take a look at line KS. Line KS. What is line KS? And then you discover that in triangle PKS, we have our angle to be A, the same angle that we have here. Okay, and then we have our opposite to be KS, and then we have our hypotenuse to be sinB. We have our hypotenuse to be sinB, but we don't know our adjacent, and then we don't know our opposite. So let's find our opposites. That is line KS. Let's find our line KS. So we're going to say sinA is equal to opposite all over hypotenuse. And then in triangle PKS, we have our hypotenuse to be sinB. Okay, now we can say that sinA is equal to, our opposite is KS, all over our hypotenuse is sinB. Is that true? Yes. In triangle PKS, we want to find line KS. Then line KS is the opposite. So we can simply make use of sinA. So we say sinA is equal to opposite all over hypotenuse. And then our opposite is KS. Our hypotenuse is sinB. So we are looking for KS. So KS is equal to sinA sinB. So we cross multiply, okay? So we have our KS to be sinA sinB. So as we have sinA sinB, let's label it. KS is equal to sinA sinB. And then you discover that KS is parallel to FM. KS is parallel to FM. And then SM is also parallel to KF. And then KS is equal to FM. And then SM is equal to KF. Alright, good. Now let's go. Still in the triangle PKS. Still in triangle what? PKS. I want us to find our adjacent, which is PK. Let's find our adjacent, which is PK. So let's use cosA. CosA is going to give us, we have adjacent all over hypotenuse. Then we have our adjacent to be PK. Our adjacent to be PK all over our hypotenuse. You know our hypotenuse to be sinB. Okay, now let's go. You say cos A is equal to pk all over sin B. Now let's make pk the subject. So we're going to have cos A sin B. We're going to see that our pk is equal to cos A sin B. All right, let's label it. Line pk is equal to cos A sin B. All right, yes, let's go. We have solved some portions. Now let's see. Let's take a look at the triangle OPF. Triangle OPF. So this triangle OPF is having the angle A plus B. It's having the angle AB. All right. You can simply say the angle A plus B will give us the angle of OPF. So what is the opposite side of this triangle OPF? So we have the opposite side to be PF. Now, I want to find the opposite side of this triangle OPF. We are going to say sin A plus B is equal to, it's going to give us this, the opposite is what? PF all over hypotenuse. Our hypotenuse is 1. So we have sin A plus B is equal to PF all over 1. So what is our PF? Pay attention. Now let's go. Now we discovered that we have line SM and then line PK. If you join them together, it will give you our PF. We say that SM is equal to KF. SM is equal to KF. Now, and then we know our SM to be sin A cos B. And then we know our PK to be cos A sin B. That means to find the line PF, we're going to say PK plus KF. And then we say that KF is the same as SM. So our SM, we have sin A cos B plus cos A sin B. Hello. Our line, the line PF, is having SM, which is equal to KF plus PK. So we have our SM to be sin A cos B plus our PK cos A sin B. So therefore, sin A plus B is equal to sin A cos B plus cos A sin B. Is that true? Yes. Yeah, it is true. All right. Now let's go. We have found our PF. Now, we want to find OF. We want to find our what? OF. So, let's find OF. In this OPF, and they discover that line OF is the adjacent, and then PF is the opposite, and then OP is the hypotenuse. So for us to find this adjacent, we're going to make use of cos. And then our angle is cos A plus B. Our angle is cos A plus B. So cos A plus B is going to give us adjacent, which is OF all over hypotenuse, and then our hypotenuse is 1. So cos A plus B is equal to OF all over 1. What is our OF? We don't know. But we know that line OM is cos A cos B. But we don't know what OF is. Now listen, let's go. You discover that FM is equal to KS. Hello. FM is equal to KS. And then we have our line KS to be what? To be sin A, sin B. Is that true? So, and then here we discover that line OF plus FM is equal to OM. Is that true? Yes. Now let's go. We have our FM to be the same as KS. We know our OM to be cos A, cos B. Now we are looking for OF. We want to find OF in a triangle OPF. So we want to make use of cos, our angle, and then our angle is A plus B. So cos A plus B will give us the OF all over hypotenuse. Okay, so when we have OM, we will just remove KS from OM. It will give us OF. Hello. So we have the line or the section OM. So when we cut KS out of OM, or we cut FM out of OM, so we have our what? OF. So we say to cut it off, we're going to say cos A, cos B minus sin A, sin B. Hello. Yes, that is the proof. Please, I want you to watch this all over again until you get to understand this. All right. Thank you very much for watching. See you next time.